All right. There's a couple of useful packages that I want to make sure that you're aware of. We have already seen the AMS math package. We haven't used it, but that's included in that template that we create. Some other ones that are specifically useful for us is going to be the physics package, which makes typesetting physics equations much simpler, and the siunitx package, which is used to typeset units. And that's actually a really useful one because it turns out that quantities with units should not, the unit symbols should not be italicized. So if you're trying to write a unit in math mode, you've got to take precautions to format the units correctly. siunitx takes care of all of that. And then the geometry package, which is one that we saw an option for in the wizard, that allows you to change the margins, which is very useful. I usually make my margins much smaller than what the default is. Hyperref is useful if you want to put links into your document. So if you want to create a PDF that links directly to a web page, you can use the hyperref for that. So let's look at the physics package. Which one? The physics? So if you go to the physics package documentation, this is essentially the standard format that LaTeX packages use for their documentation. It'll be a PDF that shows what the various commands or macros that are available in the package. And so this has got stuff for automatic bracing, vector notation, operators, derivatives, Dirac notation for quantum mechanics, matrix macros, so that you can easily create matrices. So if we just go down here and look at some of the commands, we've got like a quantity command, right? Which is basically all of these commands are set up to give you automatic sized parentheses. Like if you put a fraction inside of parentheses, you need to use something that will resize the parenthesis based on how tall the fraction is. So these things are set up to do that. The ones that I use the most are for vector notation. So when you start taking Calc 3 or electrodynamics and stuff like that, you get to where, well, here's like the cross product, for example. Here would be the divergence of a vector field. So there's a command for doing the divergence. Here's the curl of a vector field. There's a command to generate the curl operator. Laplacian is the divergence of the curl. So there's a command for that. Various operators, so sine, cosine, exponential, stuff like that. And then this one's the really nice one, derivatives, right? So a differential, the little dx. If you look at textbooks, the dx is actually not, the d is not italicized whenever they write dx. And so this /dd gives you an unitalicized differential even in math mode. You can take the derivative, just dvx will produce this derivative sign as opposed to having to make that by hand. And then you can do partial derivatives as well. So let's open up a new TechMaker. Oh, that's the wrong one. There we go. New TechMaker document. Try this one. Could not open documents. I always do that. Let's get rid of that. All right, so I'm going to do a wizard here. Quick start. The geometry package allows me to change the all of the margins. I'm going to set all of these to 1 centimeter. So you guys are taking modern physics, a lot of you, I guess half of you, taking modern physics with Dr. Dare, right? Mm-hmm. Does he give you little handouts of your homework?
No.
No, he doesn't?
It's a book and tells us to get.
Okay, so he gives you problem numbers. So in like his math phys class, he'll write up homework sets as PDFs, and the margins on his PDFs are like 3 inches because he uses the default margins for some LaTeX package that he uses, which assumes that you're going to bind it into a book, and so the left margin should be giant. So you're going to notice giant margins on Davis stuff. Yeah.
Does it also interpret inches?
Yeah. So IN, or I think there's several sets of units. So you can do like 1 centimeter, 1 inch, which would be IN, 1 pixel, which would be PX, and 1 point. So you can do like, I want 12-point spacing, whatever that is. Yeah.
I like 1 pixel of spacing from the edge.
But these lengths are also used for things like you can add vertical spacing to your document, and you can specify that you want it to be 12 point, whatever, however far 12 points is.
What does the Babel package do?
I don't know. Babel is probably some sort of translation thing, right? So it's got a bunch of different languages there. It's like a Babel fish. Babel fish is a translation. It's a Hitchhiker's Guide to the Galaxy reference. All right, so let's do some basic equations. I'm going to do begin equation environment, and then let's do like some stuff that would require a derivative. So let's say that we've got position as a function of x, or excuse me, position as a function of time, and then I'm going to write down velocity. So let's say position as a function of time, and then velocity as a function of time. So that's just going to be the derivative of position. So begin equation. All right, so velocity as a function of time is going to be equal to take the derivative of x with respect to t. Manually, what I would do is I would write a fraction. So there's a frac. The numerator is going to be a d. The denominator is going to be a dx. And then I'm going to do x of t. I'm going to save this, bless you, into a new document. So that I can quick build. Bless you. View PDF. What is, oh, my quick build is configured differently. So configure, I'm going to set my quick build to go back to just PDF LaTeX and then view PDF because I don't have any citations here, so I'm not using BibTeX. There we go. So here's the derivative of x with respect to, I don't want to do with respect to x, I want to do with respect to t. All right, then let's do the acceleration. So acceleration as a function of time is going to be the derivative of v, which would be equal to the second derivative of x. So I'm going to do a couple of different notations here. All right, so acceleration is the derivative of velocity with respect to time, which is the derivative of position with respect to time. So actually what I'm going to do is I'm going to put parentheses around that derivative of x with respect to time so that you can see that I'm supposed to take the derivative of that entire thing. So to put parentheses around that, if I just do regular parentheses like this, so left parenthesis, right parenthesis, the parentheses in my math equation are going to be too small. They're not as big as they should be. So to get those parentheses to the right size, what I have to do is I have to use, do I need to make this bigger? You kind of.
Mine's not working.
Yeah, mine's
All right, so
Mine's
let's take a
giving
pause.
errors that it's trying to find like bit text stuff, even though I didn't reference anything.
Oh.
That's because you need to go up here, configure tech maker, go to quick build, and turn off the bib tech.
There we go.
Is that better?
These D's are coming out italicized.
My favorite.
Greasy stuff.
So I'm trying to get these parentheses to be the right size. The way that I do that is in front of the left parenthesis, I do a left command. And in front of the right parenthesis, I do a right command. So you can do a left-right for the parentheses, the curly brackets, straight lines. What that left and right command does is it resizes that parenthesis so that it is the correct size for everything that's between the set of parentheses. And now those parentheses look correct. I would need to do that as well if I was going to have a function that took an argument of a fraction, right? So if I have a function that's an argument of just a symbol, then the regular parentheses are going to look right. But if I tried to put a fraction in as the argument, the parentheses aren't going to look right because they're not going to be sized correctly. And then to do the second derivative, I would, again, do a frac command. I would do d raised to the 2 power, and then I would do a dt raised to the 2 power x of t.
You get the weird O for Schrodinger.
Oh, the, yeah, you're right.
That's the 2 dots.
So let's write out Schrodinger's equation. In one dimension position representation. So to get the little dots over the O, you use it's basically like a command that's name is quotes, the double quotes, backslash double quotes, and then you surround what you want to put the 2 dots over. All right, so Schrodinger's equation is a partial differential equation. So we don't want to use the d over dt or d over dx. We want to use the partial derivative sign. All right, so let's see here. The time part is I times h bar. There's a command called h bar. Time derivative of the wave function. The wave function is typically written as psi, right? The same psi that ref carries. Fraction, not the d dt. This needs to be a partial derivative. There's a command called partial that does the partial d for partial derivatives. And then I want to do a partial with respect to t here. And I'm going to take the derivative of psi, which is psi, which is going to be a function of x and t. Just make sure that that looks right so far. All right, so there's the left side of Schrodinger's equation. Right side is negative h bar squared over 2m, and then the second derivative with respect to x. So this should be a fraction with a partial raised to the 2nd power, partial t raised to the 2nd power, psi X and T. This would be the free particle. And then if I wanted to add a potential, I would do a plus V of X times psi X and T. So we have all the commands that we need to write your basic differential equations, integrations, everything that we need. What the physics package does is it writes some commands that sort of do this automatically for you so that you don't have to keep typing the frac partial over partial command over and over and over again, right? So this is exactly how I wrote my partial derivatives for the 10 or 15 years. I just found the physics package this semester somehow. I don't know if it's new or if I just didn't ever know it existed, but it's got a lot of nice commands for doing this kind of stuff. All right, is everybody to where they wants to be, or is anybody having trouble? Okay. Oh, that's not a partial derivative with respect to t. That one should be x.
Oh. Oh, I forgot. I was kind of worried about that.
Uh-huh.
Let's try to run that. There. Why is it saying I'm missing dollar signs?
Because you're missing dollar signs.
Because you gotta return it in your equation. What? Delete the extra space from your equation.
The bottom line, is it blank? Delete it.
Yeah.
Yep, don't put that in there.
I just figured that out.
Like a boss, Corey.
Oh, and then we'll scanning
I
this
wrote
up
the
frac.
program for Latex.
Oh, good.
Just making sure you're teaching it.
Yeah,
Line 1.
just right up your alley.
Kind of looks a lot like what you had.
All right, so let's see what the physics package has to offer. For derivatives, there is a dv command. All of these are aliases, basically. The long form, if you wanted to make it clear what this was doing, would be a derivative. But you can also just use dv for shorthand. So dv with one argument creates the d over d, whatever the argument is. dv with two arguments basically takes the derivative. So this is the derivative of the first argument with respect to the second argument. And then if you want like a second or third or a fourth order derivative, there's an optional argument to the dv command, which will then put whatever you put in that optional argument will be put into the superscript for the d and the bottom thing. And then you can also see that apparently the d's in these derivatives should not be italicized. These should be differential d's, which is not what we have in the current case. And then there's a partial derivative version for everything too. So you just do pdv and you'll get partial derivatives. So let's do that. Let's rewrite this stuff. Wait, that's not what I want. Let's rewrite this using the physics package. So right under here, actually, let's just rewrite Schrodinger's equation first.
You just copy and paste.
Nope. I gotta practice. That's how I get better. I times h bar. This is going to be pdv of psi as a function of x and t. And that will be t. That's probably not actually what I want because that's going to put the uncontrolled. So pdv is not found. I have to add the physics package. So to add the physics package, all of the packages are added up here in the preamble. So just go up here and we need to add a use package command.
You just hit tab.
Oh yeah. Oh, to go between them. Thanks.
Did you have that?
I did, but I wanted to get rid of that. Oh, to go to the next one that didn't have the square brackets. I could hit tab.
Oh,
I didn't want the square brackets on this, although it probably wouldn't matter. So add the physics command or the physics package and see if we get the same error. Physics.sty not found. So we got
need to download it then.
So we got to figure out how to install it. So
It's in
I'm,
mine.
what is it in?
It's in mine.
It's in yours.
The newer version.
Maybe it has a different name. But it's just physics.
It's going to be one of the LaTeX packages. So let's look for, what distro are you using?
Debian testing is where Boltzmann.
Debian, okay. Let's do LaTeX physics package.
Mine is 4.5.
And let's see, Debian install. It's probably in a package called like extras or tech maker. Tech Life Science. Did we install Tech Life Science?
No.
Physics. Okay, so it looks like the physics package is going to be in the Tech Live Science package. So let's try that. Let's open up a terminal.
We might need to take the science tab off as well. There's documentation files for the Tech Lab Science.
Oh, we don't need documentation.
You don't need documentation?
Implementation is for
It's all online.
instructions.
So this is a package.
I hear you saying stuff like that.
Well, this is a package manager package that contains a bunch of extra LaTeX packages that are useful for science stuff. Can't believe that got through. How did we not install that when we installed everything else? Now let's see if that works. And it does. All right, so I have this derivative, this partial derivative with respect to t, and psi is up here in the numerator. I don't want that, so all I have to do is move that out. Remember that there was a pdv command that took just one argument, and it would just generate the partial derivative with respect to that argument without anything in the numerator. So that should be formatted the way I want it.
Sounded way
There we go, that's better.
Undefined control sequence.
That means you've mistyped a command name, or you didn't get that package installed yet. Did you do the use package at the top? Okay.
Front slash, right?
//
H bar space / PDB. Oh, PDB, sorry.
I don't like that H bar doesn't have an autocomplete.
You don't, what'd you say? Oh, it doesn't
H bar have an
autocomplete?
autocomplete, so it makes me feel like it's not working right whenever I try checking it.
Fraction negative, negative h bar squared
There we go.
over 2m. All right, so then for the second derivative, I'm going to do a pdv square bracket 2 times x. This is with respect to x, psi of x and t. There we go.
I use parentheses or curly brackets.
For what? After psi, I have parentheses. Those are the parentheses that are the argument, like the function argument.
Okay. I just can't.
Which one?
Or maybe not.
I'm gonna make this font bigger.
H bar squared. Curly bracket. Square brackets. No, those are curlies. On the two? Yes, but that's an optional argument.
The two needs to be square. Those are square brackets.
Four is cheap. I need curlies. See,
Yours is probably D2 over DT.
Yep. So word.
Yeah, it can pop.
If you don't put the curlies, it still accepts it. It just doesn't put anything around.
Okay. Is it not installed yet, maybe? You have your used package.
I told it rather produce. I mean, she wasn't gonna be much help.
The same letter.
Come on.
Hey.
P and Q, D and V, all the exact same. Yep, E and C is tough. All right, everybody good? Let's see if there's a derivative function. Yeah, this one right here. So let's do, grande. dvx parentheses grande. Let's see how that works. That is automatic braces and spacing. It's a long form. So let's see. I'm guessing that what we do is,
Sans grande gives you the nice inline.
yeah. Sans grande. Where do you see sans grande at? Where?
Oh, without it. That's what sans means.
No, I know, but where is that
Right
at?
below it.
Right below this?
Yeah.
This doesn't have.
What? There's making stuff up. What do you mean?
It doesn't have grande in it. That's what sans grande means.
Yeah, but that's not the only difference. This has got like two arguments. These are curly and these are non-curly.
That's
It's
Spanish.
just
Sans serif, you know the font that doesn't have the little serifs on it?
Latin.
Yeah. And
All right, let's try this. Let's try this grande. Let's see what it is. So I've got,
No, sans.
let's do product rule. Begin equation. So the product rule apply to the product of two functions f and g, which are functions of x. So I'm going to do a dv with respect to x, and then I'm going to put a grande in here. See what happens. G of x, f of x, close parentheses.
So is that are those?
Grande does not. Are those what?
You got a curly bracket in a parentheses, right?
I do.
Like for before grande, is that a curly bracket?
So these are curly brackets right here around x.
Yes.
And before grande, I just have a parenthesis.
What was grande parentheses? Error.
Doesn't like grande at all.
Ooh.
Yours did?
Oh no, actually put it over grande.
You must not have put the backslash in front of it.
Yeah.
Okay, so here's what the deal is. Grande is just a placeholder to say, put your argument in here. So if you do dv curly brackets x, and then just use parentheses, those parentheses after the dv command are going to be automatically sized. So you don't have to put a left and a right command in front of the parentheses.
Oh, they're just saying that
They're grande parentheses, yeah. So it looks like I'm,
Paragraph ended before true practice. Oh, because
so this would be the quotient rule now. Quotient rule is just the product rule. Would be the first times the derivative of the second. dvx plus the second times the derivative of the first. There we go.
That's the quotient.
Well, this is the product rule applied to quotients. So I've got the first times the derivative of the second function plus the second times the derivative of the first function. What's that?
So you made that really complicated.
Yeah, but now I don't have to remember the quotient rule.
That's true.
So this business about like what size your parentheses are, what size the integral sign is, whether or not the D should be italicized or not, that's really a lot of details that we don't care about. But it matters if you're trying to format something that looks professional. So we can use this physics package to just take care of that stuff automatically. The other one that's very, very useful, which is the last one that I'll talk about today, is the units package, siunitx. So let's go add the siunitx package at the top.
just a long list.
It's a long list of stuff that we're importing at the top. Yep. And then it's like, ooh, AMS fonts. Could I get rid of those? I don't know, so I better not try. Let's just leave it there. We know it works now. Okay.
Now I'm really curious. I'm going to see one of his scripts.
So siunitx looks like it didn't cause a problem.
Promising.
Yep, that's promising. All right, so let's do some basic stuff. Let's do there are. So when you have a quantity with units, we're going to use the SI command, capital S, capital I. First argument is the numerical value. Second argument is the units. And the nice thing about the units is you write them out. So let's do 1 meter is equal to 100 centimeters. So SI1 / meter is equal to 100. I do the centi command and then the meter command. Since I've got an equal sign here, I'm going to wrap these in dollar signs. Or 1,000 millimeter. No, that's not written right. Let me get rid of this text here.
It says one.
All right, so things to notice, the meter command that I put in for the units automatically turned into an M. If I want to use SI prefixes, I use a command for each prefix. So the centimeter gets turned into CM, millimeter gets turned into MM. Let's do units for area. So let's do a meter squared. So a meter squared would be written out as meter squared instead of doing a √2. The nice thing about this is that it looks like it's a little bit more verbose in terms of what you have to type, but you can change the style of how units are formatted by just changing some options to the siunits command. So for example, if I put a √2 for something that was squared, well, what if I wanted to change it to where it just wrote out the units twice? Or if I had stuff that had negative exponents, how would I tell it that I either wanted it to use negative exponents or to actually put them down in the bottom of a fraction? So by writing it out, you will let the package determine how it's going to be formatted, and then you can control how it's going to be formatted. So 1 meter squared is equal to 100 squared, so it'll be 100 and 100 centimeter squared. Close that. Squared D.
Error line 1.
Error line 1, the very first one.
File ended while scanning the use of.
That means that one of your equations didn't properly finish. You probably forgot to close.
Like if you left off a curly bracket,
Yeah.
or you put too many curly brackets in, it'll do that. So it opened up a curly bracket, it's trying to figure out what the units are, and then it ran into the end of the file.
Can you really have like, I don't know, like,
You have to
game on where it's, I used it over ampere squared.
We're going to do that. Use per, there's a per command.
A space, and I didn't need
So it doesn't know any conversions itself.
No, it doesn't know any conversions. All this is doing is formatting the units for you. Because the other option would be, the alternative, what you would initially try to do is you'd say 1 meter is equal to 100 centimeters. Right, maybe you've got some other math that requires you to be in math mode, like you're trying to use a Greek symbol or something. So you have to be in math mode. Well, now the units here are italicized, which is not the correct way to format those units. So then you have to go back in there and try to tell it not to italicize the units. If you use the SI unit package, it handles all of the correct formatting for you. And it even handles, if you're going to have units that have things in the numerator and the denominator, it'll format it. You can either have it formatted as a fraction with the numerator and the denominator, or just formatted as powers, the negative powers being the things that are in the denominator, or formatted as an inline fraction where it's just a single backslash. So to do fractions, or to do powers that have things in the denominator, units that have things in the denominator, let's see, let's do meters per second and meters per second squared. So 1 or SI 10 meter per second is equal to 1,000 centimeter per second. And it puts the fraction or the negative exponent up here for you. If you don't like that, which I don't, there's an option to have it do the fractions, to actually do a meter over second.
How would we go about changing that?
Let's figure out what that is. So I'm going to do SI unit X. Of course, Yahoo doesn't find anything. SI unit X. And here is CTAN. Here's the package documentation. And let's look for fraction. Okay, here we go. So I can give optional arguments to my SI command, and per mode is the option that I want to change to fraction. If I want that to be global, meaning I want it to work on the entire, so you can see what it does right here. If I want that to work over the entire thing, there's a way of setting the SI, the SI unit configuration, which is what? SI settings. Let's do per mode. See where per mode shows up here. Right there. Oh, maybe I just need to get an old LaTeX document and copy and paste it in there. There it is, SI setup. So I can do an SI setup and give a bunch of options that I want to be used for the whole document. And I would do this at the top in my preamble. So let's add the per mode to be fraction at the very top of our document. SI setup per mode equals fraction. Now I've got meters per second in fractional mode.
Per tack mode.
Yep, per tack mode. SI setup, all lowercase, curly brackets, per tack mode equals fraction.
I had an SI set up before I.
Included the package. So SI setup needs to come after SI unitx command.
Needs to go before or after this? Yeah.
So you have to do use package first because the SI setup command isn't available until you include that package. What's it complaining about?
Undefined control sequence millimeter.
Millimeter is two commands.
That's spelled millimeter.
So it's milli, M-I-L-L-I, and then slash meter.
I had one L.
I don't do
Equal
it.
fraction or tack fraction?
Classic.
Equal fraction. So the option is per mode, and you're setting that to fraction.
Yeah.
Let's do here. Let's see what is what's Coulomb's constant.
If I remember right, it's a really gross number.
It's like 8.99. Where's the numerical? Here we go. Here we go.
Oh my.
So it's 8.99 times 10 to the 9 Newton meter squared per Coulomb squared. So let's format Coulomb's constant. I'm going to come down here to the bottom. Coulomb's constant. Nice thing about SI, the SI unitx package is that I don't have to worry about whether or not I'm in math mode or regular mode either. All of the, now I might have to be in math mode if I want a specific symbol to be in there, like epsilon or something like that. But the units and everything will be formatted the same whether or not I'm in math mode. So in this case, I'm just going to do 8.99 E -9 Newton meter. What's that?
You missed the curly bracket.
Oh, I am. Good eye, good eye. Newton meter squared per Coulomb squared. I do the exponential notation, and then the SI unitx package automatically puts in the times 10 to the -9 format. If I don't want that, there's an option to configure how scientific notation is displayed. Lowercase e, yep. Otherwise, if I was going to try to type this out without using the SI unit package, to get that superscript. I can't do superscripts outside of math mode. I have to be in math mode to do superscripts. So what I would do instead is open up math mode, do an 8.99. There's a command called times, which is that big X for the multiplication, times 10 to the -9. And then I also would have to stay in math mode to put the superscripts on the unit symbols. So I would do a fraction, a Newton, a meter squared, and in the denominator, it'd be a Coulomb squared. Compile this. The number part almost looks right. The problem is that if I have a superscript that contains more than one character, I have to wrap it in curly brackets. So I'd have to put a curly bracket around this -9. So that's now correct, but my units are all italicized, which I don't want, but I can't move them outside of the math mode because I won't be able to do superscripts or fraction if I do that. So then I'd have to go through each one of these and wrap them in a text command, which then unitalicizes them, puts them in text mode instead of math mode. So this is just a giant hassle, honestly. So I either do that, or I just learn how to use the siunitx package. Don't worry about how to format units ever again. All right, you guys have a good weekend. And we'll start VI editing on Monday. Well, it'll be Vim, but we always just say VI. Nobody uses VI, real VI. Because Vim is VI improved.